And you want to make appropriate recommendations to address adverse conditions, which does not include giving specific individuals. If you have an issue with something in the electrical system, the appropriate recommendation is action recommended, or whatever term you want to use, by a qualified electrical contractor. And notice I didn't say licensed. That's because with my Prospex materials, there's a glossary that goes with it, and the term qualified is defined in that. So by simply saying qualified electrical contractor, it's enough to say. The general and specific implications. The state of Arizona, for instance, requires that you put the implications of adverse conditions. They also require in Arizona that you put in every single thing that is in the state of Arizona Board of Technical Registration components and systems. Even if they're not there, they have to be in your report. Doesn't matter, so it's boilerplate. And if they find they're not in there, they'll bring you on the carpet. Know your standard. Again, we're not there to look at adequacy, effectiveness, and efficiency or causes. So whatever we find when we're inspecting, whether it's on cooling systems or plumbing systems, it doesn't matter. And we all know we're not required to determine compliance with codes, regulations, installation guides, and so on. This is important. The decision to operate any heating and cooling system always has to be at the sole discretion of the inspector based on the inspector's evaluation or assessment of conditions at the time. And with heating and cooling systems, that can be very important in terms of outside temperature, for instance, above which or below which you don't operate certain heating or cooling system components. Now we're going to talk tonight about split systems. We're not going to talk about evaporative coolers or individual room air conditioners or anything else. We're going to talk about split systems. And as it says, it's basically, as we know, a mechanical indoor air cooling system. It incorporates a compressor, condensing coil, an evaporative coil, and an air handler. And it moves the air through a system of ducts. And the two coils are separated from each other, that is split. And the compressor circulates a refrigerant between the coils. I keep hitting the wrong button there. The basic components, obviously a thermostat to control the system operation, the outdoor unit which houses the fan, condenser, coil, and compressor, the indoor unit, typically either a furnace or a fan coil, which houses the evaporator coil and fan to circulate the cooled air, copper tubing to carry the refrigerants, an expansion valve which regulates the amount of refrigerant going into an evaporator coil, and the ductwork which allows it to circulate. We have to remember a little bit of our high school physics, not much, to understand how air conditioners work, and they're actually pretty simple. A refrigerant is a compound that absorbs heat easily. And so you have a refrigerant, in the old days Freon, and nowadays different materials, and a compressor. And when you compress a gas, it gets hot. And so the compressor, when it's in the cooling mode, comes on, the refrigerant gas is compressed, it rises to a temperature of as high as 150 degrees. I'm hearing noise in the background. There we go. That 150 degree refrigerant in a gaseous form, in a vapor form, goes out through a set of tubes in the condenser, and air is pushed across it or pulled through it, which drops the temperature of the refrigerant gas to the point that it becomes a liquid because it's cooled down. Now, cooling is a relative term. It may still be 100 degrees, but it's in a liquid form. And that's why when you have a compressor and it's operating in the summer and you have, say, a fan in the top of the compressor, which is how most of them are nowadays, you put your hand above that grill, above the fan, and it's hot air because it's taking the heat off of that refrigerant gas in order to get it cool enough to become a liquid. And it's continued to circulate up through a filter dryer, which is a little black piece. I don't know if you can see my cursor when I point to things, and on through an expansion valve, which allows that liquid to go from a liquid state to an atomized state, just like spraying out of a spray can or your mother's old perfume bottle with a little bulb on it. And when something, hello?
We can see it.
You can see it, okay.
Yes.
When it passes through the expansion valve, it goes from high pressure to low pressure, and it becomes tiny, tiny droplets. So you've got a lot of surface area. And those tiny droplets are pushed up through the evaporator coil, which, as you know, looks kind of like a big radiator, and air is blown over it. Now remember that refrigerant is something that is able to absorb heat easily. So as that house air is blown across the coil, which is now filled with this atomized liquid refrigerant, it causes the temperature of the refrigerant to go up again because it's blowing warm house air through this very cold refrigerant. Anybody who's ever taken a can of spray air for cleaning the computer and sprayed it on their hand knows it comes out cold. It's going from high pressure to low pressure. So in a sense, air conditioning systems don't put cold in, they take heat out, and the result is a drop in temperature. Well, now you've got the refrigerant returned to a gaseous form because it's heated back up by the house air flowing through the evaporator, and it's returned to the compressor where it starts the cycle over again. And it's the same thing that's happening in your car air conditioning system. It's the same thing that's happening in your refrigerator. It's all the same type of system. So really pretty simple. And as long as we understand that they work by high pressure, low pressure, liquid, gas, and how those change states, change phase, then we understand the basics of how air conditioning systems work. This is a split system heat pump. Same thing, compressor outside. Inside you have an air handler with an evaporator coil, and generally you may have some electric strip heaters in there for when the heat pump is not capable of producing enough heat. But in the air conditioning mode, it's working the same way an air conditioner works on a standard furnace, gas-fired furnace with a split system air conditioner. The difference is that the heat pump can act as a method of providing heat as well as providing chilled air, cold air. And you see up there where the cursor is, that's the reversing valve. When it's in the cooling mode, you can follow the arrows. The gas can't go over to one side. It goes down in the red dots, passes through the outdoor coil, air is blown across it, becomes a liquid, comes back in through a check valve because they don't want it going the other direction when it's in the heating mode. And from there, it goes up through a filter dryer, which is designed to take contaminants out, back down and around through the metering device, the expansion valve, and into the evaporator coil where the house air is blown across it. It returns to a gas form and goes back. When you go into the heating mode, you notice the valve up here is switched over to the other side. Now what it's doing is taking heat from the outside air, and the inside coil is acting like the evaporator coil, the condenser coil on an air conditioner. It's just working, it's basically an air conditioner working in reverse. But the thing about an air source heat pump is that depending on where you are and how cold the air is, they can be more or less efficient. Here in Colorado at high altitude, we're a little above a mile here, we don't have as many molecules of air in a given volume of air, so there's less heat for it to carry. And we have cold temperatures, so most air source heat pumps here in Colorado, no matter how efficient they are, will also have backup electric strips in them, often marked as emergency heat on a thermostat, but they're designed to come on when you're just not getting enough heat out of the air. And it just runs it backwards. Yeah.
How likely is it for the reversing valve to fail?
Very unlikely. They're pretty sturdy devices. Like any component, they can fail, but very seldom have I run across a failed reversing valve. Would not say they can't, but very seldom. More often than not, something else, another component in the system fails and has to be replaced. Oftentimes an electrical part or other component. And there, go back in the heating mode. As I said, you see it goes the other direction and just basically dumps the heat that it's collected from the outside air through the indoor coil, which now acts as the condenser, and it returns it. It's a very, very clever system. And of course, there are other sources.
Would it be more appropriate for us to call the exterior unit instead of, say, the condenser evaporator?
You can call it the outdoor coil.
Okay.
Just like it says here, if you would like to. Because it's a condenser when it's working in the air conditioning mode. It's an evaporator coil when it's working in the heating mode. And you make a good point. Our business is a technical business. We need to use correct technical terminology. Thingamabob and doohickey don't work for us. And that doesn't apply simply to air conditioning systems. I've had to correct inspectors over the years. Don't call the device on a wall that you insert a plug end into to turn on a lamp the plug. It's the receptacle outlet. It's not the plug. An outlet in electrical terms is any place that the electrical system is open to the room, to the outside, where it comes out of the wall or the ceiling or the floor. It's an outlet. Receptacle means you put in a device that receives the plug end of something that you're going to plug into it. But we'll go on. The purpose of a filter dryer is to reduce the potential for contaminants, such as water, to mix with materials in the system and produce acids. And it reduces the potential for impurities to contaminate the control element, the capillary tube or expansion valve, as well as for contamination of the compressor itself. So the filter dryer is on there for a purpose. Sometimes you'll see them, sometimes you don't. Generally, best practice is to locate the filter dryer as close on a split system air conditioning system, as close to the evaporator coil as you can, so that it catches stuff early before it enters the evaporator coil. There's a picture of a filter dryer. And if you see them, obviously you're going to look at it, and if it looks like it's damaged or rusted or otherwise, it's an adverse condition and you're going to report it. As I said, the heat pump uses the same compressor condenser as a non-heat pump split system. However, the heat pump has the additional components which enables them to pump refrigerant heat in either direction. So it provides both heating and cooling, or can. When we talked about heat pumps include a reversing valve, a bidirectional expansion valve, and in modern heat pumps, often these two valves are incorporated into a single valve, into a single component. And an accumulator. Now, you typically won't see the accumulator. It's usually inside the case holding the compressor. There's an example of some heat pump reversing valves. Some HVAC contractors call them the cigar. If you can't find a data plate that says it's a heat pump, you can look down in through the top of the compressor typically, and if you see this, what they call a cigar, that's the reversing valve. There's an accumulator, but you can see there's the compressor next to it. It's inside the case. You're very likely not going to see that. Its function, it's on the suction line, return line of a heat pump, close to the compressor. It acts as a receiver during the heating and defrost cycle when system imbalance or overcharge from field service could result in excessive liquid refrigerant, which can damage the system. It can store the refrigerant until needed and feed it back into the compressor at an acceptable rate. So it protects it against slugging. And slugging is simply, remember our physics, you can't compress a gas. You can compress a gas, you can't compress a liquid, which is why hydraulics work. You move the liquid at one end, it moves at the other, but gases can be compressed. And if liquid refrigerant enters the compressor, I keep get my hand off my mouse. It will fall directly into crank coil and eventually cause the lubricating oil to foam. You can burn out a compressor because it won't lubricate properly. And so the accumulator reduces the potential for this to happen. And I want you to be, you want to say something? I will mention something right now. You'll notice I use reduces the potential for. This is something I emphasize. There's a reason they don't call them vapor barriers anymore. They call them vapor retarders. There's a reason your watch isn't waterproof, it's water resistant. Barrier and proof are absolute terms. And we don't like to speak in absolute terms because then we're held to that level of the statement that nothing will ever happen. So you'll see a slide a little later which talks about using the word or the phrase consistent with, and again, reduces the potential for, increases the potential for, but not eliminates or prevents. when the outside temperature is below 65, in order to reduce the potential for damage to the compressor, when to operate it. Only when the outside temperature is below 65, and that means take the temperature around the compressor. If the compressor's on the north side of the house, don't go to the south side where the sun is shining, or the east side where the sun has come up in the morning. Measure the air temperature around the compressor. That's the temperature you want to be aware of. For more information regarding heat pumps in the heating mode, I'll give you a little time to write this down. There's a very good Prospects article on this. You can go in and read it and learn a little bit more about heat pumps in the heating mode. Always note where your thermostat is set before you operate the heating or cooling systems, and return those thermostats to the original settings after completing the inspection. That's critical. When to operate in the cooling mode. Heat pumps, cooling systems, and central refrigerated cooling systems, split systems, should be operated in the cooling mode only when the outside temperature has been at or above 65 for a minimum of 24 hours prior to the inspection, or for sufficient time to allow the oil in the compressor to reach a viscosity which will permit it to properly lubricate the compressor. So if you can't do it, simply note in your report that the compressor was not operated due to outside temperature. And you've covered yourself, but you want to say so. When the temperatures permit operation, before switching a conventional gas or electric furnace and heat pump split system, cooling system, from heating to cooling or vice versa, give it a little time to let it finish its cycle. If it's in the cooling cycle when you go in the house in the summer, let it shut itself off at whatever temperature the thermostat is set.
Kevin?
Hello?
I have a question.
Yeah.
When that outside temperature, the ambient temperature, the 65 degrees, does that apply when there's a heating belt around the compressor, keeping that oil warm? You still?
Yeah, some compressors have heaters, both split system regular air conditioning compressors with gas furnaces, and some don't. But I would still say, I'm not going to take the chance. I'm going to just not operate it. And I don't have the instructions for it. I don't know that the heat belt is working. That's me. I'm not going to operate it if the outside temperature is not up to 65.
Thank you.
Once it finishes this.
A quick question. So if if the air temperature right now is 75, but it dipped to 50 last night, you're not going to operate it.
No, I didn't say that. I said take the temperature of the compressor. Take the temperature. If the temperature is, and remember, 65 isn't a magic number. It could be 64. It could be 62. The idea is that you don't want the oil that lubricates the compressor to get so thick, to have such high viscosity that it won't circulate.
I'm going to ask everybody, please hold your questions. If you have questions, please enter them in the chat. Do not interrupt the speakers, please.
Thank you. Once it's run through its cycle, turn it off. Wait at least 5 minutes, then switch it back on to the next mode. If it's in cooling, let it finish its cooling cycle, turn it off, wait 5 minutes, turn it back into, put it back on into heat, if that's what you're doing, and vice versa. It's important to do this because the refrigerant needs time to go back to its starting pressure. Forcing the unit to start running while the pressure is still high can cause the compressor to lock up and increase the electricity that it's drawing, which can blow a fuse or trip a breaker. Excuse me, when switching between heating and cooling, don't set the temperature to something drastically different right away. Obviously, if you're cooling and the house is at, by the thermostat, 72 degrees, you're not going to set it at 71. Set it down to 68. Don't make it drastic, and raise or lower the temperature by a few degrees at a time. Now, when you're inspecting a central system, we're going to look at the exterior components to inspect. You want to be aware of the location of the compressor condenser unit. While typically ground mounted on a support pad, they can also be roof mounted and connected to an air handler. An evaporator coil may be located in an attic, or it can be a roof mounted package unit that contains everything in the package. It contains the evaporator coil, it contains the burners if it's a gas fired furnace, it contains the air handler, everything. And depending on the part of the country you're in, you will see these in different places. And down in Phoenix, I used to see these mounted on the roofs all the time. This is a roof mounted package unit. There's your service disconnect, there are your supports, there are your flashings. And it simply says here, where's the condensate discharge? It's on the other side, we just can't see it, but there should be a condensate discharge. We'll talk about those in a while. With ground-mounted compressor condenser units, the support pad should be impervious to moisture and to insect and vermin damage. It should be protected from direct roof runoff. In other words, if it's under an eave where roof runoff would run directly on top of it, that eave should be guttered. The water does not need to run directly into the compressor. Generally, the rule is it should be level within 10 degrees, because when it's significantly out of level, the oil in the system gets off to one side, and depending on what they're using to move the oil through the system, some of them use a slinger, it won't pick up enough oil. So always, if it's not within about 10 degrees of level, note that in your report as an adverse condition. It should be away from clothes dryer and gas-fired appliance vent terminals. Clothes dryers because you don't want all the lint and the hot air blowing on it, and vent terminals for, I think, obvious reasons. Away from airflow obstructions, bushes, walls, and so on. 12 to 18 inches minimum on the side and 5 feet minimum above. And not adjacent to a condensate discharge outlet that's going to soften the soil, because often they're set on soil where you have a basement or a crawl space, on soil that was put in as backfill after the foundation was poured. So you don't want to soften that soil by discharging condensate into it. You want to look at the condenser coil fins, or the outside coil fins, in this case we'll call them. Are they clogged? Are they dirty? Are they obstructed? Are they damaged? Look at them from the inside where you can see through the top as well as the outside. Protective fan and outside coil grills, are they missing, damaged, or missing parts? You want to look at that. Is the refrigerant suction line damaged, missing insulation, damaged insulation, stressed because the system is tilted? It's putting a lot of stress on the refrigerant lines. Same with the suction line. Accumulator, if you can see it, is it damaged? I said you typically won't. And the filter dryer, if present on the liquid line. Electrical components that may be damaged or loose. Any valves that are visible that are damaged. Exterior electrical service disconnection means if it's not located within sight of the exterior unit, if it's loose, if there's damage to its housing or the conduit between the disconnect and the compressor condenser, if it's not protected against unauthorized access, children, and at least 5 feet or greater from a pool or spa. And the reason for the protection from children, we'll see here in a minute. If it has a sight glass, ignore it, because there are too many factors that you're not going to be aware of, and you don't have a full service history to understand the limits of a sight glass. There's a pull-out cartridge fuse disconnect. All right, those things are often within 4 or 5 feet of the ground. Sometimes they're on the side of the unit. Child pulls that out and sticks something in there where the blades go in. No, that has to be secured. Should have a little lock on it or some method of securing that cover so a child can't get into it. There's airflow obstructed by shrubbery. Here's a picture, a little diagram. The unit is out of level, number 1. 2, airflow is obstructed by the shrubbery. 3, it's located beneath an eave with no gutter. Water drains directly into it. It's near a clothes dryer vent, and the refrigerant lines are now stressed because of its movement of the pad. Condenser coil location requirements. Here you have under a deck or other surface above it. You see 4 to 6 feet recommended. 5 feet is sufficient. There's a condenser coil that's obstructed by debris, leaves, and so on. Here's one that's obstructed by cottonwood cotton. We have a lot of cottonwood trees out here in Colorado, and in a good spring, they'll put out all of this fine cotton, they call it, into the air. I've gone on commercial jobs where there are multiple air handlers on the roof of a flat roof of a commercial building, industrial building, and literally been able to take a blanket of cottonwood cotton off the coils. So you want to look for obstructed. There's hail damage. We get that out here in Colorado. There's dog urine damage, as you can see. You want to always note any damage to those. So it should be in direct sight within 50 feet of the unit. And it can be in a separate enclosure, or it could actually, if your distribution panel, as you see over here on the right, is on the same, is within sight of the unit, and it's within 50 feet, you don't have to have a separate disconnect. You'll notice in the box over here on the left, you see two hots and a ground. You don't see a neutral, do you? Here, where's the grounded neutral? It's not necessary. One of the 120 volt or 125 volt measured hot conductors is always alternating in opposite of the other. So when one of the wires is bringing in current, the other is returning it to the panel and completing the circuit. Thus, one of the others acting as the neutral, and both the compressor and the condenser motors are typically 240, unlike a closed dryer, where you have to have a neutral, because you've got a 120 volt circuit as one of those incoming 120 volt legs for a 220 closed dryer, and it's operating the motor that turns the drum and the dryer. That's a 120 volt motor. The motor are the elements that provide the heat for the dryer are 240. So the difference, if one leg is pulling of the 240 service, if one of the 120 volt legs is pulling, say, 23 amps and the other is pulling 17 amps, that means that you have 6 amps running on the neutral, which is why you now have to have a ground with range ovens and clothes dryers, because you will actually run current on the neutral, but not with the air conditioner. Oh, I don't know if any of you have ever seen this, but I have seen the copper tubing put in place of cartridge fuses. No, nope, don't want to see that. You should have, and this is more recent in terms of, the last 50 years, certainly, a receptacle outlet for use by the service technician, so they can plug their equipment in that they need to use while they're servicing a unit. So whether it's in an attic, in a crawl space, outside, it should have a 125 volt, 15 or 20 amp GFCI receptacle outlet installed within 25 feet of it. And there you can see there's a compressor on the lower left corner, and there's the disconnect with also with a 125 volt receptacle outlet in it. If you have roof mounted units, I know there are people from Florida and other parts of the country, all electrical should be installed in electrical metallic tubing or in liquid type flexible metal conduct. Other HVAC wiring should be installed in conduit appropriate for the location. Low voltage wiring is required to be protected, but it's a good idea, because if the insulation gets brittle because of exposure to weather, it can short out on the two wires or two or more wires in the control, the 24 volt low voltage. If one shorts out against the other, it can blow the controls, and now your thermostat's not going to work. So it's not required that they be in any kind of conduit, but it's not a bad idea to protect them. If conditions allow the system to be operated, listen for atypical noise and vibration during the operation of the compressor condenser. After the system has been in operation for 15 minutes, the suction line should be cold to the touch, should not be frosted or ice coated, and the liquid line should be hot to the touch. Frost or ice on the suction line may be caused by obstructed airflow due to a dirty coil, dirty air filter, collapsed duct insulation, a number of factors. But if you see the frost and ice, then you write it up as an adverse condition and call for a qualified HVAC contractor. One of the things that you can do in the winter when you can't operate a split system compressor condenser on a regular, say, gas-fired heating system, you can't operate, but you can still look at the compressor to see if it's level. You can still look at the insulation on the refrigerant lines. You can still look for damage and obstruction of the condenser fins. And I've actually looked down inside and seen cracks in the fan blades where they're starting to fatigue. I also used to carry about a 15-inch long fiberglass knitting needle and I would just stick it in between the grill and make sure that the fan would spin, because whether it's on or not, it should spin. And if it didn't, it was seized. So there are a lot of, and you can look, see there's a gutter over the compressor condenser if it's under a roof eave. So there are things you can do to still inspect the system. You just can't operate it. On roof mounted units, always look at the supports, the flashings, make sure they're away from any roof mounted closed dryer vents and gas fired appliance discharge terminals, away from airflow obstructions, just like before. And make sure the condensate discharge piping is not damaged or improper location or obstructed. Now there's a low exterior condensation drain adjacent to a foundation. Not such a big deal perhaps on a slab on grade home, but it may be on a home with a crawl space or a basement. Also in areas where you have a roof mounted or attic mounted, I should say, air handler, you're going to have two condensate discharges. One for the primary pan that normally drains the condensate off the evaporator coil, and a secondary pan in case the primary pan becomes clogged or the drain becomes clogged. And the secondary pan should drain to the exterior. And in my view, and certainly in certain parts of the country, like down in Phoenix, they want that secondary pan drain to be up high where you're going to see it dripping. The primary can be down low, but if you see it dripping, you know there's a problem with the primary. So they want to see it up high. Some people suggest you bring it out and let it, a little ways out from the wall, let it drain in front of a kitchen window. So if you're standing there and you see water coming out of it, you know that you've got an issue with the primary condensate drain. Heat pump compressor condenser, non-heat pump compressor condenser units don't need to be covered. In fact, it's recommended that they not be. The manufacturer makes those things to be exposed to the weather. If you put a full cover on it, it can't breathe. You can get condensation underneath the cover. You can get corrosion of the components inside. So if it has a cover at all, it should be a cover like this. And that's just to keep debris out, leaves and other things when it's not in use. A lot of inspectors like to look at data plates and start trying to interpret them and determine whether this is right, wrong, or whatever. One of the biggest things they use them for is determining the age. And if they've got a furnace or compressor or air conditioning system, Atlas, they can look at the brand and the serial number, which is often where they code the year of manufacture. And they'll say, well, gee, this was manufactured, it's 2021, this was manufactured in 2020, it's 21 years old. I want to go back and remember that the purpose of scope, you're to, according to ASHI, to their standard, you're to report components that are near the end of their service lives. Well, that may be easy enough to do on a roof covering, but not so. You're not required to give the remaining life expectancy of systems and components. And furthermore, age alone does not determine whether an air conditioning system is near or at the end of its life. Unless you have the service history and the use history, how often it was used, how many months of the year, how often it's been serviced, you can't look at it and say it's 21 years old and is approaching the end of its life. If you operate it and it performs its normally intended function and operation, produces cold air, it's not making funny noises, condensate's coming out the condensate drain, it's not appropriate to recommend that it be replaced or they consider replacing it in the near future. Home inspectors aren't fortune tellers and you're not required to predict the future. And so my suggestion is don't do that. Instead of assuming that a unit's at the end of its life based on age or near the end of its life, consider recommending that the system be serviced by a qualified HVAC contractor, even if you find nothing particularly wrong with the system, unless it's been done within the last 12 months and that all such systems be serviced by a qualified HVAC contractor annually. That's just good boilerplate to put in a report. Now we get into the interior components. This components to inspect. You've got a blower fan and an air handler case connected to both supply plenum and containing an evaporator coil and both the chilled air distribution duct system and an air return plenum and duct system. When you're looking at the fan, which is usually a squirrel cage fan, look at the rotor blades inside. If they're covered with dust, dirt, drywall debris, excuse me, tongue twister, write it up and call for service. with air conditioners, dirty blades on a squirrel cage fan can reduce the efficiency of the system by as much as 10%. Also look at the ends of the motor. The motor depends on air being pulled through as the fan is operating to cool the motor. If it's caked in dust and so on, which is usually the case if they haven't changed filters on a regular basis, write that up. We know where they can be installed. We talked about that. You want to look at the air handler for damage or missing parts. We said dirty, damaged support or suspension components, not delivering cold air, filters missing, dirty, or damaged, blower dirty, damaged, atypical noise during operation, and older models, maybe even a damaged drive belt, and suction line damage, insulation damage, and so on. So for all those things, we're looking at it on the interior of the house. Using a space between joists for return is pretty common where you have a basement or even a crawl space. However, it should be sealed. It shouldn't simply be a piece of sheet metal nailed to the bottom of the two joists. There should be a sealant tape or sealant sealing it all the way around, making sure all of these joints are sealed. As for running a support column through the center of it, there's nothing that says you can't. You are obstructing the airflow a little bit in the return, but you should also be sealing it around where that column passes through the sheet metal. Some inspectors may elect to measure the air temperature difference or split between the return plenum and the upstream of the blower and the supply plenum downstream of the evaporator coil as part of their evaluation. It's not required by the ASHI standard. You're not required to determine adequacy, effectiveness, and efficiency. If you're going out and it's got cold air coming out of all of the registers, you've done your job. And if you've got reasonable volume, because you can talk to different contractors and they'll give you different temperature splits. Oh, 16 to 22, 15 to 20, 12 to 20, and so on. Who's correct? Now, if you, for instance, if you measure a 14 Fahrenheit difference or 13 what are you going to do with that information? If you choose to measure it and you're not getting any difference at all, you're getting like 6 degrees, that's an issue. It's not providing cold air. And it's usually because something is clogged up, filter or some other component that allows the air to be transferred through the system. What about airflow and volume? Both air temperature and discharge volume are dependent on the system design and parameters. Factors such as duct length, type, configuration, support, joint linkage, and so on all affect temperature and volume. So again, I've been in a house where it's a very long ranch house, and you go back to the master bedroom, which was as far away from the air handler as it could be because the air handler was in the garage. They were getting almost no air discharged over that length into the master bedroom, which I wrote up. Because it wasn't, and it was producing mildly cold air, but not. And I asked the occupants, they said, yeah, we've never been able to get this bedroom very cold when the air conditioning's on. So they make fans that can be put in duct systems, booster fans. There are ways that can be addressed. If you have crimped ducting in an attic, for instance, and I saw a lot of that down in Arizona because we had so many houses that were built slab on grade, the ducting ended up in the attic. And first, most of that insulated ducting, it's very common for it to be corrugated on the inside. So you're already disrupting the airflow a little bit. You start doing this and you're not going to get good airflow at all. Your best thing with flexible ducting is to use it for long straight runs, and where possible, make any bends as gentle a bend as possible, as wide a radius of bend as possible. But if you saw that in an attic, you should write it up. I've had to correct inspectors on this for years. Don't confuse one or the other. Register is a grill with moving parts capable of being open and closed into direct airflow. A return grill has no parts. Don't confuse them.
Kevin, let me interrupt for just a minute here. Just for planning purposes, Mike did show up and is waiting. So you've got 15.
All right, I'll wrap it up here in 15, and then as I said, there's a slide at the end that tells people where they can get hold of me.
Okay, thanks.
You know, air handlers can be installed, as I said, attics suspended from rafter roof set on a platform, top of ceiling joists or bottom cords of trusses, in interior mechanical spaces and basements. I've seen them in garages. An important part of a cooling system is the condensate collection and discharge. You're not required to assess the design of these systems, only determine if they're damaged or causing adverse conditions, which can be detected in accordance with the contractual scope of inspection, visual, readily accessible, and so on. You'll have a primary collection pan. If you have evidence of leaking or obstructed drain, write it up. Secondary collection pan where it's required, say like in an attic unit, damage, debris in it, evidence of leaking, improper slope, obstructed. In some cases, you'll have a condensate collection discharge pump where the condensate, say, is being discharged into a crawl space and it has to be pumped up and out of the house. A discharge piping system. And you want to look for whether it's clogged, damaged, evidence of leaking, improper installation, traps, cleanouts, and so on. They're configured in different ways, the drain lines, depending on the location of the air handler and the location of the coil. Units located horizontally in attics and crawl spaces will have a secondary condensate pan, as we said. Other areas may also have condensate collection pans. When the blower is located upstream of the evaporator coil, pulling air through the coil, the condensate drain line should include a trap, because otherwise the moisture will be sucked out. And I'll give you an example here in a minute. Some condensate collection and discharge systems may incorporate a safety switch designed to shut the AC off when condensate collection and discharge system is obstructed or otherwise not working. They have a little float in them. And if it's not draining, the little float rises as the water rises. It's connected to the controls for the system, and it just shuts it down. There's some good examples of evidence where condensate has been leaking. You can see here staining on the wood platform, rust in the secondary pan, rust around the plenum in this case. Inspect for evidence of that. Inspect for debris or insulation in secondary collection pans. You're not required to place water in them and see if they drain, but there's a good example of a collection pan that had been collecting water at one time. Look at all the rust in it. This is just one schematic of a condensate drain line system. And they should have a clean out in them in case they become obstructed. They can run a flexible brush down through them and clean them out. You notice here you have a horizontal clean out over here, 2 vertical clean outs. A lot of times they'll be put together with a union here so they can actually take the pipes apart and work on them if they need to. That's just one example of a condensate drain line schematic. When you have a trap, if you have air blowing across the condensate line, positive airflow instead of negative, you're just going to be blowing air out the vent. And that doesn't work. Correct is to put the vent on the other side of the trap, and then the trap condensate stays in there and acts as a trap so you can't get airflow back the other way. There's a safety switch right there, and there's a clean out brush leaning up against it. You notice they have a cap here so they can go in horizontally and clean that out as well. There's another safety switch there. You've got a secondary pan here. Primary pan is inside under the evaporator coil. You'll notice that they have secured the pan, and they've also secured the drain lines. Here they used plumber's tape or holy iron, old plumber's terms for that material. And they've secured the pan as well. That's a good job there. It's a well-designed and installed condensate drain system. In some areas where you have high humidity, they will insulate the condensate drain because the cold water temperature may cause humidity in the air to condense on the outside of the drain line. It'll sweat, and this can result in moisture dripping off the line and damaging materials beneath the drain line. So it's not your job to say it should have it unless you see evidence that it has been sweating. If you're in a climate, Florida or someplace where you have high humidity, we're very fortunate out here in Colorado, we don't. If an evaporator coil is located on a roof-mounted unit, the condensate drain line is exposed to the sun. It has to be made of a material that's impervious to weathering and UV damage, ultraviolet. PVC pipe is not appropriate unless it's properly coated with a UV-resistant paint or otherwise protected from direct exposure to sunlight. Otherwise, it just becomes brittle and it breaks. And there you see PVC being used as a condensate drain on a roof-mounted unit. And that was down, I think, in Arizona, and that got written up. You also see wiring here, which is control wiring just lying on the roof. No, not a good idea. There's an example of a little float switch, a diagram, cross section of a safety switch. And there's the wiring going back to the controls to shut it off if water starts to rise and closes the switch. If it can't be drained, as I said, if you can't drain condensate to an appropriate location by gravity, then a pump has to be installed to pump it to an appropriate location. That's what they look like generally, and that's kind of a cross section. Condensing furnaces, gas furnaces, whether there's air conditioner or not, create condensate. So they have to have a condensate drain. And then you add to that here a condensing furnace with an evaporator coil. So you're draining the evaporator coil up here. You're draining the condensate from the condensing furnace down here. You notice down here it says condensate neutralizer. That's because the condensate coming off of the furnace when it's in the heating mode is slightly acidic. It has nitric acid in it, and so they put a neutralizer on it, usually a cartridge that gets replaced periodically. And then down to a condensate pump, which is pumped in or connected to rather a GFCI receptacle. So you look for primary pan evidence of leaking, secondary pan, and so on. We talked about that. Pumps, emergency shutoff devices, and associated electrical parts. Discharge piping system is clogged, damaged, leaking. All of those things are things you want to look at. The interesting thing is that when you become an inspector and you've done it enough, you look at these things almost taking them in all at once. You focus in once you see something. You look at the system with what I call spotlight vision first, then you go to floodlight vision, then you go to spotlight vision and focus in on things. And there's just an example of where the condensate drains would be in an upflow and a downflow furnace, vertical furnace. There's the same picture showing how it's secured and where the safety switch is. There's a nice example of horizontal flow. They've got a safety switch, they've got vents, they've got traps, they've got pipes from both of them. And you can see that the air handler itself is sitting on some blocks, but we also have some straps that are suspending it. Condensate discharge on the interior can go into a laundry sink. It can go into the tailpiece of a basin drain. It can go into the overflow of a bathtub, but it can't go directly into a plumbing stack. And you don't want to just stick it in the ground either. But these are appropriate, and I've seen these. I've seen them drain into a laundry stand pipe, which is fine because it's still above the trap. And there's evidence of condensate leakage. If you see it, write it up and report it. There's what I said I was going to say earlier. Don't guess. Describe what you see and know, not what you don't. Very seldom are we present when an adverse condition occurs. When it's suspected but can't be definitively determined, consider using the phrase consistent with. Corrosion and staining consistent with condensate leakage are present around and beneath the area where the condensate drain exits the air handler. You looked at it, it was dry, you didn't see any liquid, maybe it's in the winter, it's not operating. Consistent with. Instead of saying it is this, it is that. And that pretty much ends the presentation. Again, thank you. And here, I'm going to leave this up. If you have any questions or comments pertaining to the presentation or its contents, would like a free copy of this presentation, or have any questions regarding the services Prospex provides, feel free to email them to me along with your phone number, or you can call me. And with that, I will say thank you. I hope this has been useful.